If you have ever heard about bonds but felt confused about how they work, how to value them, or how investors measure risk, then this video is for you. Today, we'll dive deep into what bonds are and how they're priced, and why the concepts like yield, duration, convexity matter to every investor. A bond is simply a financial instrument used for borrowing money. When you buy a bond, you're essentially lending money to an issuer, like the government or a corporation. In return, you receive a periodic interest payments, commonly called as coupons. And at maturity, you get your principal or face value back. The two most important dates are when you receive the coupons and when the final maturity is paid to you. The price of a bond equals to the sum of all its future cash flows, both the coupons and the face value at maturity, discounted back to the present using the current interest rates called the zero rates. These zero rates are the discount factor which we use to bring down the overall cash flow which we get from the bonds to the present value. So why do we discount the overall cash flows of a bond to find its actual bond price at the present value? The simple analogy is that what $100 means right now might not be the same in the future. So if I can get something for like if for example if a bag of rice is for like $10 right now, in the future due to price changes and inflations and other system changes, the same bag of rice might cost somewhere around $11 or $12. So those $12 in the future is discounted or equal to the $10 right now, because we are getting the same value out of it, which is a bag of rice. So that is why we need to discount the overall cash flow of a bond to the present value to find the bond price at that present time. So the bond price at present is equal to the sum of all cash flows, CI, discounted by the zero rate and time, which is E to the power of minus the zero rate into TI. Now imagine a semi-annual coupon bond of face value 100 and coupon rate 6% and maturity in 20 months. The price is the total of all discounted coupon payments plus the principal using the formula. Now that we understood what bond is and how to calculate the bond price at a particular time, let's look into a key parameter called the bond yield. Yield is the most talked about number when it comes to bonds. But what is it? Yield is the single constant interest rate that makes the present value of all cash flows from the bond exactly equal to its current market price. The formula for yield says that the bond price should be equal to the sum of all cash flows CI discounted with respect to the yield, which is Y. So this formula can also be written as this after a few approximations. So bond price can be written as the sum of all discounted cash flows, where the discounted cash flow is given by CI by 1 plus Y to the power of TI, where I goes from 1 to N. To understand yield better, let's look into an example. First, suppose the face value of a bond is equals to 100 and the coupon rate is equals to 6% and maturity is equals to 3 years and current market price is equals to 98 per 98. So the bond pays 6 units every year as coupon. And at the end of 3 years, it pays back the 100 units, which is the face value. So we can write this as B is equals to 6 by 1 plus Y plus 6 by 1 plus Y square plus 6 plus 100 by 1 plus Y cube. So now if we equate, B is equals to 98 then we have only one unknown factor, which is y, and which is the yield. So we calculate this as 1 plus y plus 5 plus 1 square plus 6 plus 5 plus y cubed. So after calculating this, we can say that the yield is approximately equal to 6.69%. So if you understand the example, we can see that if we know the current market price of the bond, yield is that rate or that discount rate which we should use to discount the overall cash flows which we get from the bond to make sure that the current market price of the bond is equal to the discounted cash flow which we get from the bond. This is also called the internal rate of return for bonds. That the higher a higher yield means a lower bond price, and vice versa. To find yield from price, we often need to solve this equation numeric. Now, the par yield is nothing but the coupon rate that makes the bond's price equal to its face value. The market interest rates are positive. This yield is uniquely determined and is vital for comparing bonds. Now that we understood what yield is, let's look into another key term called duration. Duration tells us how much a bond's price will change if the interest rates move. It is the time-weighted average of cash flows discounted by the bond's yield and divided by the bond's price. The higher the duration, the more sensitive the bond is to interest rate changes. So the formula for duration is this: D is equals to summation of Ti into Ci into e to the power of minus YTI, which is the discount factor. This is called the discount factor by the bond price from I is equals to 1 to n. N is the number of cash flows which we get from the bond. Now, from this equation, we can infer that the rate of price change of a bond is approximately equal to the product of minus of duration into the change in yield. For example, if bond's duration is 2 years, this was 2 years, and the yield increases by 1%, or the change in yield is 1%, then the change in price or the rate of change of price is approximately equal to minus of d into delta y, which is equal to minus of 2 into 0.01, which is equal to 0.02, minus of 0.02, which is equal to minus 2 plus. This means that for a bond whose duration is 2 years and there is a 1% increase in the yield, the price of it lowers by 2%, or there'll be a change in price by 2%. From this, we can say that a small increase in the yields causes a price drop approximately proportional to the duration. Now that we understood what duration is, let's look at another term called convexity. Convexity measures how much duration changes as yield changes. It refers to our sensitivity measure. So the formula for convexity is sum of Ti squared into Ci into e to the power of minus YTI from I is equals to 1 to n whole by the bond price. So we can say that convexity is equal to the discounted value, the sum of all discounted values of cash flows into the Ti square or time square whole divided by the bond price. Higher convexity means the price falls less when yields rise and rises more when the yields fall. This is a favorable feature. For larger interest rate changes, convexity correction makes a big difference in some estimating price changes. Let's look at an example to understand this better. For suppose there's a bond with D is equals to 5 years, C is equals to 80. Convexity is a unitless measure, and B is equals to 100, and delta Y is equals to 1%, or there's a change in yield by 1% in positive 0.01. Now, the formula for approximate percentage price change with respect to duration is delta B by T is approximately equal to minus T into delta Y, which is approximately equal to minus 5 into 0.01, which is equal to minus 5%. Now, from the equation of convexity, we can say that the formula for percentage of price change is approximately equal to delta B by B minus D into delta Y plus half of C into delta Y squared. This is the correction term. So to calculate this, we get the approximate value of minus 4.6%. With convexity, the expected price drop is smaller, about 4.6%, reflecting the bond's price sensitivity more accurately. Similarly, if the yield decreases by 1%, the price change using duration only would be 5%, but with convexity, it would be 5.4%, or the price rises by 5.4%. This demonstrates that higher convexity makes bond prices less sensitive to yield increases and more sensitive to yield decreases, improving the precision of price change estimates, especially for larger interest rate movements. Convexity, convexity thus refines the duration estimate by accounting for the curvature in price yield relationship. This is about bonds and important features of bonds like the price of a bond, the yield of a bond, the duration of a bond, and the convexity of a bond. Thank you.